Hello, today we're going to be talking about the trig functions and right triangle trig ratios. So what exactly are the trig functions? To visualize the trig functions, we have a unit circle on the left with point J which has been graphed. We can draw a line from point J to the x-axis in order to create a right triangle. And there are three sides of a right triangle relative to angle theta. The first is the hypotenuse, which is the longest side of the triangle. Then there's the opposite, which is the side that is directly opposite to the angle theta. And then adjacent, which is the other side of a triangle that isn't the hypotenuse. To memorize these three main trig functions, we use SOHCAHTOA. Sa is sine of theta, which would be opposite over hypotenuse. And then we have ka, which is cosine, which is adjacent over hypotenuse. And finally, we have toa, which is tan of theta, which is opposite over adjacent. Now there are three more trig functions: cosecant, secant, and cotangent. Now these three functions are the inverse of the three main sine, cosine, and tangent. Cosecant is the inverse of sine, which is hypotenuse over opposite. Secant is the inverse of cosine, which is hypotenuse over adjacent. And cotangent is the inverse of tan, being adjacent over opposite. Now let's move on to an example question. So the question is asking us to find the cosine of angle JKL. So angle JKL would be JKL. So this is angle JKL. To find the cosine of this, going back, cosine is the adjacent of angle theta over the hypotenuse. So we need to find the adjacent and hypotenuse of angle JKL. Now, with the point J that has been given to us, we know that the x is 4, which means that this side is 4. The adjacent is 4. And then the y, which is 6, would mean that the opposite is 6. So cosine means adjacent over hypotenuse. So we know the adjacent, but we need to find the hypotenuse. To find the missing side of a triangle, we need to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So we know a squared and b squared, so 4 squared plus 6 squared would equal c squared, which is the missing side or the hypotenuse. So 4 squared plus 6 squared equals 52. So that would mean 52 equals c squared. To get c alone, we need to take the square root of both sides. So that means that c equals the square root of 52. And you have to be very careful because even I have made a mistake here in which 52 has not been simplified to its more simplified form, which would be 2 square root of 13. So so we're going to substitute that into the cosine formula, which is ka, or adjacent over hypotenuse. So the adjacent of this angle JKL is 4, as we had concluded earlier, and the hypotenuse, which is 2 square root of 13. So the answer for this problem would be 4 over not square root of 52, but the simplified form, 2 square root of 13. Now we have a different example problem. This one asks us to find the cotangent of angle JKL. So now we have a different set of numbers for point J, which is 6, 8. So as we know from before, 6 would represent the adjacent side and 8 will represent the opposite side of angle JKL. Now, if we remember back at the beginning, the question had asked us to find the cotangent, and cotangent is the inverse of tangent of tangent. So tangent is opposite over adjacent, which means that cotangent is the opposite, adjacent over opposite. So that means that we'd need the adjacent and the opposite side relative to angle JKL. So we have both opposite and adjacent, which means we don't have to use the Pythagorean theorem as we had in the last problem, because it's not necessary for us to find the hypotenuse. So now we just need to substitute that into the formula. Adjacent, which is 6, and over the opposite, which is 8, which means that the answer for this question is 6/8.